Implementation of the Fujian Aircraft Carrier Battle Group's Advanced Combat Systems by 2024. Overview. The Fujian Aircraft Carrier Battle Group is poised to become a significant player in naval warfare with the implementation of advanced combat systems anticipated to be completed by 2024. This initiative is backed by a substantial investment of $1.8 billion and is structured around 4 critical milestones, each designed to enhance the operational capabilities and strategic positioning of China's naval forces. Key milestones. 1. Initial funding in Research Phase 2022. The project commenced in 2022 with the establishment of initial funding and a comprehensive research phase. This stage was crucial for developing the technologies necessary for advanced combat systems. The focus was on integrating cutting-edge sensors and weapon systems, ensuring that the Fujian aircraft carrier could effectively operate in modern combat environments. This phase involved extensive collaboration between military experts, engineers, and researchers to identify the most pressing technological needs and allocate resources effectively. 2. Prototype Development 2023. By mid-2023, the project transitioned into the prototype development phase. During this period, various prototypes of the combat systems were constructed and subjected to rigorous testing. Key components such as advanced radar systems and electronic warfare technologies were developed to enhance situational awareness and defensive capabilities. This milestone was critical for identifying potential technological gaps and making necessary adjustments before full-scale production. The focus on real-world testing scenarios aimed to ensure that all systems met the operational requirements expected in potential conflict situations. 3. Operational testing and training late 2023. Following successful prototype testing, the late 2023 period was dedicated to operational testing and personnel training. This phase included simulations of diverse combat scenarios, allowing naval personnel to familiarize themselves with the new systems and ensure their readiness for deployment. Extensive training programs were established to equip the naval forces with the skills required to operate and maintain the advanced combat systems effectively. This focus on human factors was essential as it ensured that the technological advancements were complemented by a highly trained workforce capable of leveraging them in a combat environment. 4. Full-scale implementation 2024. The final milestone is the full-scale implementation of the advanced combat systems aboard the Fujian aircraft carrier, targeted for completion by 2024. At this point, the carrier is expected to be fully operational with upgraded combat capabilities. This implementation will enable the carrier to project power effectively in regional conflicts, enhancing China's naval presence and operational readiness. The strategic positioning of the Fujian Carrier Group is set to significantly alter naval power dynamics in the Asia-Pacific region, reflecting broader geopolitical shifts. Investment strategy. The investment strategy of $1.8 billion is structured to support the 4 key milestones, ensuring the project remains on schedule and within budget. The funding is allocated as follows. Research and development R&D. A significant portion of the budget is directed towards R&D, focusing on the integration of artificial intelligence, cyber warfare capabilities, and advanced weaponry. This investment aims to ensure that the Fujian carrier is equipped with state-of-the-art technology that can respond effectively to evolving threats. Testing and prototyping. Financial resources are also allocated for extensive testing and prototyping, allowing for the identification and rectification of potential issues before full-scale production. This phase is critical for ensuring that all systems function as intended and meet the operational standards required for modern naval warfare. Training programs, recognizing the importance of personnel readiness. A portion of the budget is earmarked for comprehensive training programs. This investment in human capital is essential for maximizing the effectiveness of the advanced combat systems and ensuring that naval personnel can operate them proficiently. Operational readiness. Finally, funds are allocated for the full-scale implementation phase, ensuring that the Fujian aircraft carrier can achieve operational readiness by 2024. This includes the installation of advanced systems, final testing, and preparation for deployment. Conclusion: the implementation of advanced combat systems in the Fujian Aircraft Carrier Battle Group represents a pivotal development in China's naval capabilities. The structured approach, encompassing 4 key milestones and the significant investment of $1.8 billion, reflect a commitment to enhancing operational readiness and strategic positioning in the Asia-Pacific region. As the project progresses towards its 2024 completion target, the implications for regional power dynamics and naval warfare will be profound, marking a new chapter in modern military capabilities. The implementation of advanced combat systems in the Fujian Aircraft Carrier Battle Group is projected to significantly enhance China's naval capabilities with a strategic investment of $1.8 billion by 2024. This initiative is structured around 4 key milestones, which include initial funding and research, prototype development, operational testing and training, and full-scale implementation. 1. Initial funding and research phase 2022. This phase focuses on securing the necessary funding and conducting research to develop advanced technologies for the carrier. The integration of sophisticated sensors and weapons systems is a priority aimed at ensuring the Fujian can effectively operate in contemporary combat scenarios. 2. Prototype development 2023. By mid-2023, prototypes of the combat systems are expected to be developed and tested. This includes the introduction of advanced radar and electronic warfare systems that enhance the situational awareness and defensive capabilities of the carrier. Identifying technological gaps during this phase will be crucial for adjustments. 3. Operational testing and training late 2023. After prototype testing, a phase of extensive operational testing will commence. This will involve training naval personnel on the new systems to ensure readiness for deployment. Various combat scenarios will be simulated to evaluate the effectiveness and reliability of the systems. For full-scale implementation 2024, the final milestone involves the full-scale implementation of the advanced combat systems aboard the Fujian aircraft carrier. By 2024, the carrier is expected to be operational with upgraded combat capabilities, positioning China to effectively project power in regional conflicts. Counterintuitive information. 1. Investment versus operational capability. While the $1.8 billion investment suggests a significant enhancement of capabilities, it may be counterintuitive to assume that financial investment alone will lead to effective operational readiness. The complexities involved in integrating advanced technologies, training personnel, and ensuring operational effectiveness may not directly correlate with the amount of financial investment. 2. Technological gaps. The emphasis on identifying technological gaps during the prototype phase might suggest that the initial designs are insufficient for current combat scenarios. This could imply that despite the investment, there may be inherent risks in relying on newly developed systems that have yet to prove their reliability. 3. Human factor in training. Although advanced combat systems are technologically sophisticated, the effectiveness of these systems heavily relies on the training and readiness of personnel. This reliance on human factors can be counterintuitive, as it emphasizes that even the most advanced technology requires proficient operators to be effective in combat. For geopolitical implications, the development of the Fujian Carrier Group with these advanced systems could alter regional power dynamics in ways that are not straightforward. While it may enhance China's naval power, it could also provoke countermeasures or escalations from rival nations, potentially destabilizing regional security rather than strengthening it, which counters the assumption that increased military capability leads to stability. In summary, while the structured approach to implementing advanced combat systems in the Fujian Aircraft Carrier Battle Group reflects a significant investment in military modernization, the complexities and potential risks associated with such advancements highlight a range of counterintuitive considerations that go beyond mere financial metrics. The report on the implementation of advanced combat systems for the Fujian Aircraft Carrier Battle Group outlines a significant modernization effort for China's naval capabilities. With an investment of $1.8 billion and a completion target of 2024. While the report highlights 4 key milestones in this process, several nuances and implications may be overlooked by the general readership. Below are some important points that merit deeper consideration. 1. Integration of artificial intelligence (AI) and cyber warfare capabilities. While the report primarily discusses funding, technology integration, and operational readiness, the potential inclusion of AI and cyber warfare capabilities warrants attention. These advancements can enhance decision-making processes, improve threat detection, and offer strategic advantages in asymmetric warfare scenarios. The significance of AI in military applications is profound, as it can lead to real-time data analysis and predictive capabilities that traditional systems lack. This can change engagement dynamics significantly, enabling quicker countermeasures and more effective resource allocation during conflicts. 2. Human factors and personnel training. The emphasis on technological advancements should not overshadow the human element of military operations. Training naval personnel to effectively utilize these new systems is crucial, yet often underreported. Human-machine interaction will be a critical area of focus as advanced systems are integrated. The effectiveness of these technologies ultimately depends on the operator's ability to understand and leverage them in combat situations. The investment in training programs and simulations to prepare personnel for these advanced systems can significantly influence operational success and should be highlighted as a key component of the implementation strategy. 3. Geopolitical implications and regional stability. The report briefly touches on the implications of China's naval modernization for regional power dynamics but does not delve deeply into the potential for increased tensions in the Asia-Pacific region. The enhancement of China's naval capabilities could provoke responses from neighboring countries and alliances, such as the United States and its allies. The implications of this modernization extend beyond mere military readiness. They could alter the balance of power and influence stability in a region already marked by territorial disputes and strategic rivalries. Analysts and policymakers should consider how this modernization might affect diplomatic relations and military posturing in the area. 4. Logistical and supply chain considerations. The timeline for completing the advanced combat systems by 2024 is ambitious, and the report does not sufficiently address the logistical challenges associated with such rapid modernization. Supply chain disruptions, whether due to political factors, economic conditions, or the ongoing effects of the COVID-19 pandemic, could impact the availability of necessary components and materials. Understanding these logistical challenges is vital, as they can introduce delays or compromise the quality and readiness of the deployed systems. It may be prudent for stakeholders to assess the robustness of the supply chain and develop contingency plans to mitigate potential risks. 5. Environmental and ethical considerations. With advancements in military technology, there are often ethical considerations regarding the use of such capabilities in warfare. The report does not address the potential for increased lethality and the ethical implications of deploying advanced combat systems that incorporate AI and autonomous functions. This raises questions about accountability and the moral responsibilities of military actions. The discourse surrounding the ethical use of technology in warfare is increasingly important and should be part of the broader conversation about military modernization. 6. Potential for adaptation and innovation. The report indicates a planned approach with predefined milestones, but the potential for innovation and adaptability in military technology should be emphasized. As new threats emerge, the ability to adapt existing systems or develop new capabilities will be crucial. This flexibility can determine the effectiveness of the Fujian Aircraft Carrier Battle Group in real-world scenarios. Stakeholders should consider mechanisms for continuous improvement and innovation within the framework of military modernization. In conclusion, while the core elements of the report provide a clear roadmap for the Fujian Aircraft Carrier Battle Group's modernization, the overlooked aspects, such as AI integration, human factors, geopolitical implications, logistical challenges, ethical considerations, and the potential for innovation, are equally significant. Understanding these nuances can provide a more comprehensive view of the broader impacts of this strategic investment and modernization effort. 1. Investment and economic implications. The $1.8 billion investment in the Fujian Aircraft Carrier Battle Group highlights China's commitment to enhancing its naval capabilities, reflecting its strategic military ambitions. This financial commitment signifies a broader trend towards military modernization in an era of increasing geopolitical tensions, particularly in the Asia-Pacific region. An in-depth analysis of the economic impact of this investment on both domestic and international stages could reveal how it influences global military dynamics, defense spending, and international relations. 2. Technological advancements in naval warfare. The implementation of advanced combat systems, particularly the integration of artificial intelligence and cyber warfare capabilities, marks a significant leap in naval warfare technology. Analyzing the specifics of these technologies, such as advanced radar electronic warfare systems and their implications on operational efficiency and combat readiness, would provide insights into the future of naval engagements and the evolving nature of maritime conflicts. 3. Operational readiness and training programs. The milestone of operational testing and personnel training underscores the importance of human factors in military effectiveness. A detailed discussion on training methodologies, the integration of simulation technologies, and the preparedness of personnel to operate complex systems can provide valuable insights into how militaries ensure operational readiness amidst technological advancements. This aspect also touches on the broader implications of workforce development in defense sectors globally. For strategic positioning within geopolitical contexts, the full-scale implementation of these advanced combat systems by 2024 could significantly alter the balance of naval power in the Asia-Pacific region. An analysis of how this development interacts with the military strategies of neighboring countries such as the United States, Japan, and India, as well as regional alliances, would highlight the increasing complexities of international security. Assessing the potential responses from these nations could also lead to a deeper understanding of future conflict scenarios and diplomatic strategies. Here are 3 famous historical cases that reflect similar themes of advanced technological implementation and military strategy. 1. The Manhattan Project 1942–1946. This was a secret research and development project during World War II that produced the first nuclear weapons. The United States, with support from the United Kingdom and Canada, invested around $2 billion, equivalent to about $26 billion today, in this ambitious endeavor, which involved significant milestones such as the development of the atomic bomb. The Manhattan Project saw the collaboration of some of the greatest scientific minds of the time, including J. Robert Oppenheimer and Enrico Fermi. The project was marked by its rapid technological advancements and resulted in the bombings of Hiroshima and Nagasaki, showcasing the profound impact of advanced weaponry on warfare and geopolitics. 2. The Apollo Program 1961–1972. Initiated by President John F. Kennedy, the Apollo program was a series of missions aimed at landing humans on the moon and bringing them safely back to Earth. This program required an investment of approximately $25.4 billion, about $150 billion today, and was marked by significant milestones, including the successful Apollo 11 mission in 1969, which made Neil Armstrong the first human to set foot on the moon. The program not only advanced space technology and engineering but also served as a demonstration of U.S. technological superiority during the Cold War, particularly against the backdrop of the space race with the Soviet Union. 3. The development of the F-35 Lightning II 2006 present. The F-35 program, also known as the Joint Strike Fighter JSF program, represents one of the most ambitious military aircraft programs in history. It is designed to be a versatile stealth multi-role fighter capable of performing various missions including air-to-air combat, air-to-ground strikes, and intelligence surveillance and reconnaissance. The program has faced significant challenges including delays, budget overruns with total costs projected to exceed $1 trillion over its lifetime, and technological complexities. The F-35 program emphasizes advanced combat systems and technologies including stealth capabilities and networked warfare, reflecting the importance of technological superiority in modern military strategy. These cases illustrate how significant investments and strategic technological advancements can shape military capabilities and geopolitical dynamics. Much like the planned implementation of advanced combat systems in the Fujian Aircraft Carrier Battle Group. Future outlook: implementation of advanced combat systems in the Fujian Aircraft Carrier Battle Group by 2024. The implementation of advanced combat systems in the Fujian Aircraft Carrier Battle Group represents a pivotal evolution in naval warfare, showcasing China's commitment to enhancing its military capabilities. With a substantial investment of $1.8 billion, the project aims for completion by 2024, focusing on 4 key milestones that will redefine the operational capabilities of the carrier. Here we present predictions for the future based on the current trajectory of this initiative. 1. Technological Integration and Innovation 2022 to 2023. The beginning of the project in 2022 marked the allocation of funding and the initiation of research. This phase is likely to catalyze significant breakthroughs in combat technology, including the integration of artificial intelligence (AI) and advancements in sensor technologies. As research progresses, we can expect the development of systems that enhance situational awareness, including advanced radar capabilities, electronic warfare systems, and automated decision-making tools. By mid-2023, the prototype development phase will likely showcase cutting-edge technologies that could include autonomous drones, advanced missile systems, and enhanced data processing capabilities. These innovations will not only improve the combat effectiveness of the Fujian carrier but also set benchmarks for future naval projects globally. 2. Operational testing and personnel training, late 2023. As operational testing begins in late 2023, the focus will shift to evaluating these systems under various combat scenarios. Training programs for naval personnel will be critical to ensure that they can effectively operate and maintain the new technologies. This phase will reveal potential weaknesses in system integration and personnel readiness, allowing for adjustments before full-scale implementation. The lessons learned during this testing phase will likely influence naval strategies not just for the Fujian carrier but for the entire Chinese Navy. Enhanced training regimes incorporating virtual simulations and AI-assisted learning techniques may emerge, establishing a new standard for military training in naval operations. 3. Full-scale implementation and strategic deployment 2024. By 2024, the full-scale implementation of advanced combat systems on the Fujian carrier is expected to dramatically enhance China's naval capabilities. This phase will likely coincide with strategic deployments in the Asia-Pacific region, reflecting China's broader geopolitical ambitions. The operational readiness of the Fujian carrier, equipped with state-of-the-art combat systems, will enable China to project power more effectively in regional conflicts. Furthermore, the operational capabilities of the Fujian carrier will not only alter naval power dynamics in the region but also affect how neighboring countries strategize their military developments. Anticipated enhancements in deterrence capabilities may lead to an arms race in advanced naval technologies among regional powers including Japan, South Korea, and India. 4. Impact on global naval warfare dynamics. The successful implementation of the Fujian carrier's advanced combat systems could potentially reshape global naval warfare dynamics. As China enhances its naval capabilities, it may embolden its stance in territorial disputes, particularly in the South China Sea and with Taiwan. Increased confidence in naval power projection may lead to more aggressive posturing in these contentious areas. Moreover, the introduction of sophisticated naval technologies may prompt other nations to reassess their naval strategies and invest in countermeasures, such as enhanced missile defense systems or new technologies like hypersonic weapons. The interplay of these developments is likely to lead to a more complex security environment in the Asia-Pacific region. Conclusion: the implementation of advanced combat systems in the Fujian Aircraft Carrier Battle Group by 2024 is poised to significantly enhance China's naval capabilities and alter the balance of power in the Asia-Pacific region. As the project progresses through its key milestones, we anticipate technological innovations, operational readiness, and strategic deployments that will not only affect regional dynamics but also have broader implications for global naval warfare. The next few years will be critical in shaping the future of naval operations and military strategies worldwide.